Okay, welcome to this week's Retrieval Market Demo Day recording. The date is Wednesday, the 16th of February, 2022. Today, we have a few new presenters presenting for us. We have Sherlock from Meson Network, we have Edmund from New Web Group, and then we have William from Ken Labs, who we've heard from many times before, and it's always great to hear from William again. So with that said, over to you, Sherlock, for the first presentations.
Sure. Thank you, Patrick. Thanks for having me today, and nice to meet you. Nice to meet you guys all. And I'm Sherlock. I'm the co-founder of the Meson Network, and very happy to introduce the things we are building today. Patrick, can I share my screen?
Yes, of course.
Okay. Can you see my screen?
Yeah.
Okay. So the things we're building is called Meson Network, and today I want to share with you our explore about the building for bandwidth marketplace. So let's start. I'm a backend programmer, and I used to run lots of machines from like AWS or some like cloud service provider. And then I noticed, okay, in the end of each like month billing cycle, I checked detail of the usage of the machines. I found looks like around 30 or 40% of my resources is underutilized, and some of them are the bandwidth. So I try to think, can I find a way to monetize my underutilized bandwidth? And then I do some survey. I try to find, okay, well, people need this. How much will they pay for this part? And after that, I found, okay, like some short video company, they spend around $700 million per year. Only one company did spend this money for the bandwidth. So I noticed, okay, so it looks like the resources is quite valuable. But then the next part I found, why then no one just try to reach me and integrate my resources because they are such valuable? And then I found, okay, because lots of my resources belong to the long-term market, it's quite small. So the model in the right now internet world is they use the people to like have a meeting, have a call with you, you sign a contract, you make the deal to integrate resources. But if right now the resources is more distributed all around the world, so can we find a new way to aggregate these very long tail but also distributed resources? And then we try to give a solution. So we can regard this as a blockchain-based CDN service. So we use the protocol, or more specifically, we use token to incentivize our users and then let them to contribute their resources to our network or to our marketplace. So for example, you have some machines based in the data center IDC, and then you can download one of our, we call them a terminal, like a software, like a managed software, and you run this software in your machines, and then you can serve the request from the network. So this is called terminal side. And because we found that when you use the token model to incentivize the users, you don't need like the hire lots of people to one by one or to integrate different resources in different market or in the countries. You can only focus on one thing, is how to build your protocol and how to make the token, how to design a very good token model to incentivize all of the users or the entities in your system. And then you don't need, when you're opening a much bigger market, you don't need to hire, for example, 10 or 100,000 of people to help you to do the BD or do some marketing job. So that's idea we building things. And then the next part is when you try to aggregate resources from the, we call them supply side, from the nodes. So one hard problem is we need to prove that their resources contributing network is working right. For example, because the code in the this network is open source, and we are trying to solve a distributed system with all code open source. So people can very easily to change your code and they can easily do cheating. And then with this assumption, how can you design a system to solve this? So we can look at the problem or a solution happening in the storage side, like Filecoin. They use the proof. They use lots of proof steps, and then to make sure that the users or the terminal nodes, it's very hard for them to do the cheating job. And then in the bandwidth part, we also try to think, can we use this way to solve this problem? For example, we design some proof mechanism, and then use this mechanism to ensure that the resources is like we observed or working in the network. As for now, we pay lots of efforts, but we still can't find a very perfect solution. So maybe if some like other guests or other speakers, they have very good idea. We are lovely to hear from them. But for us, for now, we can't find a very good solution to do the proof jobs. And then when we're talking with my team member, we think, okay, can we think different? It's like if you're doing the proof, it's hard. Can we do another side? Like we don't care how much data you have transferred, right? We just let the network to measure your resources. So this is things happening in our system right now, and we're all still in development, but we can share some idea with you. So we call them speed testers. And then on the left side, they are just a normal miner nodes. And then in the right part, you will have some speed testers. We don't know where are they. And the job they do is they will randomly select and test some nodes to get their parameters. And if the nodes doesn't respond very not accordingly, for example, we have 2 or 3 speed testers, they test the same nodes, and then they have a different result. So during that time, we can have assumption that maybe some nodes is doing cheating job. And then, for example, in the around 1 hour later, when we speed test again the same node, and the error capacity is, for example, only half of the number before. So we can assume that they may doing some cheating job. So this is the first design called speed testers. Like here, you can see if the speed drops a lot when 2 nodes tested at the same time, like they have the correlations. So some nodes gonna be penalty. And then the next part is how to design our reward algorithm. So at least we have 2 models to solve this problem. First is like usage model, that's this strategy. So reward is based on usage, like Filecoin or like many, for example, design in the storage part. When you store the files, the more you save, the more you're gonna be rewarded, right? So like in this system, the more data you transferred, you're gonna be rewarded more. This is the first strategy. And then the second strategy is we only measure your capacity, right? So we don't care how much data, how much real data you transferred. Because if you transfer much more, you will still get the same reward. And this idea is just like we like to think about things happening in series, like they have the base reward and then they have the transaction fee. So the ranking model is much like you will have the base reward, and then the usage model is like you can add something for the transaction fee. Right now, we just try to solve the problem of the ranking part, the basic capacity, and this is Meson used. And for the real usage, we're gonna have 2 scores. The first is called bandwidth score, and the second is called storage score. Because for the bandwidth system, or we can call them the CDN system, you also need the storage, right? But the difference is you can have maybe several gigabytes, for example, one unit of the storage, and then you can compare it with 100 units of the bandwidth part. So just like stored once and be retrieval for a million times. And then the multiplier of these 2 scores will be our final score for the miners. Then the next super hard problem is still in challenge the whole system is you need to solve at least like traffic router, right? So the users based in different locations, geography locations, and the nodes also will be in different countries and different locations. So how can you use a system or a strategy to find a very good router for all of the requests, right? Right now, we are just make it much more simple, right? You have the IP geography location, and then we can have a HTTP 302 to redirect to some nodes. And then before them, we can build something called load balancer to cover the request. But I think maybe we can with the things iterate, we can find a better solution for this part. And then the next part is called scheduler system. So it's, ignore about the pictures. So this is super hard problem, I think, in the when you to match the demand side and the supply side. So we can think this model as the same thing like in the Uber, right? The Uber will have their drivers. They have a lot of drivers, the taxi, anything else. And then they will also have some clients. So for example, if you have 2 clients in this place, and then you have 2 cars near these 2 guests. So the best scheduler system or the algorithm is not let the most near car to deliver you, right? So because it will not get the whole best result. So this is called scheduler system, and it's quite like things happening in the Uber side. And this is also a thing we try to use. We use a very simple model to solve this problem. But then I think maybe in the future, some people or some scientists or some very good team, they can propose a much better model. And then we can use them to integrate into our system. And then the next super hard challenge is the token model. So when you design the like CDN service or the bandwidth system or bandwidth marketplace, we call them, you're going to have a supply and demand side. So for supply side, it's quite easy. You can use your native token to incentivize for your miners. But then for demand side, it will be a very hard problem because if you use like utility token, something like Ethereum, and then the difference is when you're using the Ethereum, people don't know how the infrastructure costs. Like when you use 1% resources from the Ethereum, in the real world, we don't know how these resources cost. So people can give a very crazy number. They say, wow, this is world computer. This is the world virtual machine. So I can think the resources can cost 100 times than the real resources. But in the CDN area, it will be quite different. So people know how the like storage cost, how the like the specific traffic cost. So when you try to prove them a new system, but with using the crypto native utility token model, it will make them confused. Okay, today I pay for your traffic with like 10 units of the money, but why tomorrow I need to pay for your 50 units number, right? So this is a problem existed to solving the system which has the target in the real world. And then the next is if you want to satisfy your users, your demand side much better, you should keep the price stable, or you should keep the payment token be very, for example, keep the same as like the stable coin. They can pay in the USD. And then above them, when you want to reach the very open users, you should say, okay, you can pay in different like US dollar, like GBP or like RMB or different currencies. You can just support them. And then in our design, we found we don't want to sacrifice these 2 things. So for your own system, you should still keep the utility token, right? You should only 1 token, and then they're gonna be incentivized for 2 sides. And then for the demand side, we should add some like plugin to help them, like they can pay in the token they own or anything they want. And then we're gonna have some third party or middleware to convert it to our native token, something like bundler for our wave. Yeah. And I also want to show you some demand side for part. So we have served like Musk. They have a checkbox here. They can use our service, and also we help like Arweave to help them to solve problem. The file stored in a Solana art, the project called DGN, and they use Arweave as a storage system, and we help them. And third is this is a benchmark page about the Meson and IPFS. So the smaller is better. So we do some benchmark and we find that we have looks like a much better benchmark result. Yeah, and welcome people to test for our service. And then the next part is we also try to compare with the right now storage system like Arweave. So also the same thing gonna happen in the Filecoin. So like storage system, they have incentivized for the storage. And then maybe we can use different system or different network to incentivize for retrieval. And then we can combine these two systems together to serve users. For example, users just want to think, okay, I just want to store the file, and then I just want to consume the files very quickly. So like things happening, Sam, they said, okay, JC's new 500 megabytes MT stored in Arweave and delivered by Meson Network. Yeah, this is the last page. Okay, you can try Meson. So right now we are still in testnet. We welcome people to test our service and to give us more advice. And also we still try to solve the challenges I mentioned before. So like when you have the URL, you add this, you check URL, you add, you're gonna have the original URL, and then you're gonna have the CDN URL, and then you can use this series. Okay, guys, thanks. That's my presentation.
Nice, thanks so much, Sherlock. That was great. And yeah, please reach out to Sherlock if anyone's got any more questions about Meson. The next speaker, we've got Edmund from New Web Group. New Web Group have just started a grant as part of the Retrieval Markets working group. And so, yeah, looking forward to this introduction presentation. Over to you, Edmund.
Hi everyone. My name is Edmund. I'm on behalf of New Web Group. I'm responsible for overseas communication and translation with to communicate with global communities, including political labs, etc. And as our international office just established in August 2021, now it's with like over 50 people overall. And secondly, the New Web Group is a storage service provider that focuses on distributed storage services and hardware researches and development, cluster storage, and IDC computer rooms hosting, etc. in cloud clustering operations. Currently has operations in Hong Kong, Singapore, and aiming for global coverage. Our vision is to build the future Web3, to provide with the customers with data safety, technology morality, and life happiness. I'll just give a brief rundown from our company's history. The founding team participated in blockchain and crypto in 2016 in May. And in 2017, September, they started to participate in IPFS and to build the technology team. And in 2019, October, the cooperations with local IDC operators. And in 2020, August, they participate in FIL and space racing. In also the Mainnet Online and with the speed update research and development. And in 2020, December, they established the New Web Group technology company. In 2021, in March, they got an round investment from QF Capital with a valuation of 200 RMBs. And in 2021, August, they have the new international offices to start doing operations overseas. The executive team, including the Troy Ni, the CEO with background in real estate and consulting, and is an early investor in crypto. And he holds degrees in mechanical engineering and the co-founder of GFIS, a fintech organization in GRC region. Also the Diamond Huang, the VP in QF Capital, the specializing in IPOs, M&As, and restructuring. And also the Axis Ouyang, the CMOs, the ex-IPFS Min Director, and the Go Crypto Exchange CMOs. And the CTO is Galen Tang, and he was a PhD in Stanford and worked for leading companies in Tencent. And Michael Yang is the president of International Division, the earliest advocate for BTC from BC Canada. And Leon Liu, the VP, the director in cloud storage cluster, and co-founder of INT supply chain. And also we have the key tech team, the Dean, the chief programmer, and Mr. Yuan, the tech VP. They both have many years experience in software development and for game, for blockchain, for software languages, including Rust, Golang, and C++, etc. I'll just, because I'm not a tech guy, so I just gave a rundown of their translated version of what's your development. If I see anything wrong, maybe you can refer to the tech team and they can give a more specific explanation. So basically, first of all, let's take example of recent NFTs. There's not a NFT projects, say in the Filecoin ecosystem. There's actually doing actual storage, because there are a lot of obstacles to get on with. So in order to solve all the problems, maybe we have 4 objectives to achieve. The first one is the need to solve the problems of real-time access. That is the allocation of network resources. Number 2, the legacy miners, the original miners, the revenues cannot be affected for them because they are doing what they do before. So the incentives is better to function in the new systems. Number 3, compared to centralized storage and bandwidth providers, the Filecoin should be able to provide competitive service with low costs, better experience, and high quality services. The number 4 we need to solve is to use IPFS protocols as a core to support and solve the problems to be more efficient, and this is to be more native, so they come together. So we're introducing the new incentive programs. We suggest that the future miners can have divided into 3 categories. They have different roles as A, B, and C, for example. Like A, the existing traditional Filecoin storage service providers, their incentive mechanism should be to obtain Filecoin rewards by providing efficient storage space resources. Their responsibility is including mainly to save multiple copies of data from miner B and to customers through encapsulation and doing offsite permanent backups. So the plan is to gradually optimize and improve the utilization rate of hardware storage, such as replacing the CC sectors of 14 EBs bandwidth EP storage with real and valid data first. The miner B, so the second miner. So the IPFS nodes builders can get few rewards. We call it miner B. So it's deployed as IPFS nodes. So that removes the Filecoin encapsulation process by storing data under the enterprise chain. For example, NFTs. Customers only need to upload to get the IPFS hash of the received content. So you can achieve real-time access to data. The data is then stored on top of 5 to 8 A miners in the next 3 to say 5 days. The reward mechanism should be like referring to the Filecoin white paper, the traditional storage rewards model design, according to the storage resources provided by miner B situation and the bandwidth qualities and bandwidth size and networking traffic actual usage, etc., etc. Comprehensive rewards Filecoin to miner Bs. And his responsibilities should including IPFS storage hardware and network resources are provided. And after the DHT perform data addressing, the data will be read and relayed through the nearest neighboring nodes with a logical distance. According to real-time data is guaranteed so as to ensure a quality experience from customers to access files. The plan for miner B is they can seamlessly access Web3 storage, NFT storage in the applications, developing by protocol labs through the ports of all storage miners on the Filecoin ecosystem. So basically the miner A is doing the copies, making the different copies, and the miner B is trying to to make the bandwidth more, to speed up the upload and download speed. So the miner C will deploy an IPFS lightweight nodes through an intelligent scheduling systems. And personally bandwidth and storage resources are composed into light nodes to release social idle bandwidth resources through greatly reducing CDN costs and providing low-cost, high-quality super CDN services for the enterprise. The incentive mechanism should be like aggregating the bandwidth resources of services providers and intelligently scheduling the demand of side of the services, accelerating the completion of the original algorithms of settlement of traffic costs, plus release the demand side of FIL tokens incentive as a shared CDN user fees. The responsibilities should be including to provide high quality and low cost accelerations for miner B and miner A to retrieve the data. So we make A, B, C as a combo so they can support a very complete, the super shared CDN concept, which can provide high quality and low costs acceleration services for data sites and short videos, live stream games, and downloads, etc. So we want to do this to implement the A, B, and C combination so that the Filecoin can have the function of IPFS and combine the Filecoin with IPFS together. So what are the benefits of doing this with Filecoin? So the proposal combined the concept of shared with idle home bandwidth resources through technology implementations and propose the concept of Filecoin shared super CDNs. So it's the high performance CDNs. So for the individual user, so for users with idle bandwidth resources, to make idle bandwidth resources more valuable, so you can use all those free resources available. For corporate user, for the enterprises, they can suffer from expensive bandwidth costs, and they can help enterprise to reduce their bandwidth costs and free up more funds for product development, operations, promotions, and other kind of stuff. For Filecoin ecosystem, it can provide high quality and low cost shared edge computing services like IoTs, and propose the new concept of miners, improving the roles of the miners and the reward IPFS system providers to make use of the user experience much better. The project code is completely open source, and all the projects are developed based on Filecoin. It will have a high quality user experience after the completion of the whole projects, and help the Filecoin to make the consensus to make the market more valuable. So the shared CDN concept for Filecoin to further achieve the carbon neutrality, it can improve the inherent image of energy consumption formed by the blockchain project like BTC and Ethereum, and truly runs through the concepts of responding to FIL green environmental protection. So the Filecoin can achieve carbon neutrality and realize the carbon negative initiatives in the time. So that's basically our idea. So I finished.
Great, thank you very much.
Yeah.
Yeah, it's very.
So maybe we'll provide a PPT after that. Maybe you can have a better idea of what's happening, and maybe give you a new link on to download the PPT. So unfortunately we don't have it ready for here at the moment. So maybe later we can have a more detailed explanation on that. Yeah.
Yeah, that would be great. Please share a deck whenever you have one ready. But it was very interesting to hear just you speaking through it and the different layers of providers, A, B, and C, and how they'd work together. So thank you very much, and looking forward to seeing how this project progresses.
Sure.
Great. And now to the final presentation, William from Ken Labs.
Thanks, Patrick. Can you see my screen?
Yes.
Okay. So we just had a break in China, 1 week break. It's a public holiday, the Chinese New Year. So we don't have too much update, but we have almost wrap up the Pando service. So I'm going to give a bi-weekly update. So it's the 16th of February, 2022. So what's new? So I want to announce that we have updated our provider metadata specification. We have some discussions with the Protocol Labs contact, Masi. So he gave us a really valuable review. So the specification has been updated. I'm going to go through shortly. So what's required? Also, we updated Pando topic, considering the future development or the different plan on the roadmap. So we consider to versioning the topic. The last thing is the updated provider integration process. So let me go to the documentation. So this is the repo for the Pando service. Okay, you can see here. So what I want to emphasize is the change of the integration. So as a provider, what we need to do, and so this is a prerequisite. This is part of the metadata specification. Any provider need to publish their metadata with the required IPLD nodes, provider, and the signature. So we need to know the provider, and the whole package, the data need to be signed with a private key. So we need to have the signature. So these are two required nodes in the IPLD data. Other than that, we accept also a previous ID, which a link to the previous metadata. So if you want to link all the data in a chain, so you can use this node. So the Pando service will also recursively think or fetch the data, the metadata. So once Pando service makes a couple of metadata update in between, so it can still catch up in the future. So this is a metadata specification. We also updated the topic to, as I just mentioned, Pando v0.0.1. So this is a topic for now we are using. And the last thing is the integration process. We have tweaked a bit of the flow. So you may notice the change if you visit before. So I moved the step building Pando service and client to the first one, as we need a Pando client to do the registration job for the provider. In the future, we may have a easier way for the provider, but for now we have to do it in this way. So we build the client, go to the bin directory, use a Pando client to register itself with a pair ID and the private key. So the private key is guaranteed. It's guaranteed that the private key won't be used other than just the signature. So it won't be shared or uploaded to any network. So also the code is open source, so we can review. So there should be no risk. The other thing is that we create a Pando SDK. I have an example here, so we can go and see it shortly. So we use the SDK to connect to Pando, initialize or build your IPLD metadata. We call the metadata instance. So you can push the metadata the last step you need to do is execute update route. So it's not explicitly mentioned here. So this is part of the Golex component. So this is how we publish the IP-ID data to the topic Pando 0.0.1. Okay, for the rest of the document, they are for the consumers. So how we can access the metadata or snapshot status, how we can access over GraphQL API. The most important thing is how we can access IP-ID data. So it's following the Golex component specification. So any consumers can also use the same Golex to fetch the data. That's the integration process. In terms of the example, so we can see here, so this is an example of the data publish. So we have a Pando SDK for the providers. So any provider can use it to easily connect to Pando, then build the metadata, and here, with the publish. And the push. So we got the metadata CID here. Which is so this is the example how we use the Pando SDK. So if anybody interested, you can go and check out the document here. And if you want to start a Pando server by yourselves, you can follow the steps here. We are using S3 gateway for the archiving. So metadata will be archived regularly and uploaded to Filecoin network. So for now, we are using this gateway. So to use it and run the server on your own, so you need to register and get your S3 API key and set it in the configuration file. It's all mentioned here. Okay, I think that's it for today. Lastly, this is the contact information of the Ken Labs. So feel free to reach out if you have any question or any interest. Thanks.
Awesome, thanks very much. Cool, well, I'll stop the recording there. Thanks, everyone.